Hello, I'm Tom Hopkins. I'm an assistant professor at Bossier Parish Community College, and today we're going to talk about conditional statements. Now what we're going to do is take a look at those statements as an overall general discussion. We're not going to talk about any specific language at this particular case. Okay, let's get started with that, and we'll take a look at these statements. In this discussion segment, we're going to talk about an if statement. Now, every language has a capability of making these decision-making structures called ifs and if-else. We're going to compare strings. Also, we're going to take a look at nesting decision structures, which really gives a computer a lot of capability in making decisions. And in fact, this is where, if it wasn't for the nested decision structure, we wouldn't even have robots, for instance. We're going to take a look at logical operators and Boolean values in this. Okay. When we take a look at different programming, what we're going to do is there are certain orders of programming, if you will. We have basically one type of programming that gives us a sequence structure. In other words, it starts from line 1, and the computer then executes each line one by one until there's no more instruction lines. The second part of that, or another type of version, is a control structure. Now, control structure gives us a capability of writing, say, 5 or 10 lines of code, or maybe 100 lines of code, and setting it aside, and then we can actually go back to it. So it's a logical design. We can go back and run that same lines of code over and over again without having to rewrite them into the sequence. It gives us a logical design that controls this order of when the statements are going to execute. Now, it's a little different than decision structure, where we're actually going to have the computer make a decision based on some parameters or statements that we've given it or programmed into it. Now, how do we do this? Well, what we're going to do is use an if statement. Now, the if statement allows us to take the computer and have the computer make a decision based on a single alternative, or maybe dual alternative, or multiple alternatives based on whether a statement is true. For instance, you get up in the morning, you get in the car. Every time you get up and start your day, you're going to make decisions based on if-else statements. For instance, you get in the car, you're driving down the road, you come to your first traffic light, and you look to see the light is red. Now that's the statement you're looking in your mind for. The light is red. If that statement is true, you'll stop. If that statement is false, you'll go. You have one alternative to the statement if it's true. Either stop or go. So stopping is part of the programming, but going is a decision you've got to make based on whether that light is red statement, if it's true or not. Okay, how do we put this together in any type of programming language? What we do is we can build the statements, whatever the language allows you, syntax of the language, I should say, the proper grammar. But whatever it is, it's all the languages are going to have the same basic idea. What we're going to do is take it, and I'm going to use a flowchart, because flowcharts are real easy to see the true-false condition and how it's tested. Also, how it's conditionally executed. And I'm going to start off with a single alternative decision structure. In other words, there's only one alternative path to the execution other than the straight line path. So let's take a look at this. Okay, in the if statement, we're going along in the programming. Let's say you're getting dressed in the morning, and somewhere along that process of getting ready to walk outside, you have to answer the question, is it cold outside? If the statement, it is cold outside, is true, then you're going to wear a coat. If that statement is not true, the programming, you'll continue getting dressed and getting your shoes on, picking up your bags and all that, and heading out the door. So you have one alternative based on whether it's cold outside. And you can see in diagramming here, you can really see excuse me, you can really see in the diagramming that how that structure works. Okay, let's take a look at another version. The algorithm, let's say you pick up the keys to go to the store. If it's cold outside is equal to true, get coat from closet, put on coat. Then the normal programming is continue outside, get in the car, start the car. You see? So the if gives you a decision based on the conditions outside. Now let's take a look at another one. An if to test two different conditions against each other. The if statement can be more than just one single statement. It can also ask, is A greater than B? Or is A greater than or equal to B? Is A less than or equal to B? Now look at this one though. If you're going to say A is equal to B, notice the condition, and almost all languages have this particular style. Instead of saying A is equal to B with a single equal sign, we're asking the question, is A equal to B? In this case, we would use two equal signs. And of course, the not equal to is fairly universal as well. So the way it would look in programming is if hours are greater than 40, do this. Wage is equal to hour wage times 1.5. If balance is equal to, payment is equal to balance, loan is paid. If these statements are not true, then the programming just continues on with its standard sequence that we've already built in it. Okay? Now, let's take a look at a dual alternative. So we're going to make a decision of either do this or do this. If this, else this. So there's two alternative capabilities, or two possible paths of execution here. One is taken if the condition is true, and the other is taken if the condition is false. So we could write it, if some condition, do this. If some condition is true, do this statement. Else, do this statement. So let's look at it as a diagram. I think it'll make more sense to you. So now we've got that same problem of wearing a coat right here. So what we're going to say is, it is cold outside. If that statement is true, wear a coat. If it's false, then wear a sweater. These two conditions, one or the other, are going to have to be made, and then of course we're going to go back to our normal processing. We can also nest these, and by nesting it, now the computer gets you get the impression that the computer is actually making decisions for itself. Of course, that's not really true, but it appears like it's true. So let's take a look at this one. If A is equal to B, then if that's true, let's take another look. If A is equal to C. If both of those are true, print B equals C. As you can see right here, though, what's happening is we've asked if this is true. Well, if that's not true, then we're going to go straight down to the else statement. We're not going to do any of this. But if this is A is equal to B is true, now ask the second question. Well, if that's the case, is A equal to C? If that is also true, print B equals C. Else, print B is not equal to C. And then this else here is not even run, you see? Because we've already made the decision that A is equal to B. Let's take a look at the diagram, make more sense. Here you can see if A is equal to B, and it's true, then ask another decision right here, is A equals C? If that is true, then B is equal to C, print this statement. If this is false, print this statement, B is not equal to C, then continue back to our normal scheduled programming. If this statement is false, then we're going to go over here and just print A is not equal to B, and we're done with it. We're not even going to ask this second question. So we've nested it. You can put the if-else statements pretty much anywhere you want. It can be like this one, like the example I just had, or we can have this example where we have the first statement, if A is equal to B, print A is equal to B. If that's not true, then else, and we can now ask another question. And then we can ask another question and another question. We keep on nesting these together until such time as the computer is actually making multiple decisions in pieces. So here's an example of what it looks like nested on the other side, on the false side. If A is not equal to B, now we can go over and say, okay, well, if that's false, is this true? If this statement isn't true, print this, and we go on with our regular programming. Okay, so we've got decision structures that we've talked about. We've used the if-else methods, and like I said, these are across the board for all languages, with some very, very old exceptions which were inline programming. We've talked about single alternatives, double alternatives, and also nested decision structures. Now from here, what we're going to do is do some other segments that we have prepared for you that are language specific. So if you're looking at one of the particular languages, then take a look at those. And thank you very much, and we'll see you next time.